Hello everyone, welcome back. Today we're going beyond the basics. We're diving deep into Linux networking. In today's video, we will cover interfaces, routing, DNS, firewalls, remote access, and even how to monitor and secure your network. Whether you're on RHEL or using a Debian flavor, the process is still the same for like maybe 90% the same for whichever flavor you're using. So let's get started. For this video, I think it would be best suited if I give a breakdown of what is a network and the component that make an IP address and how we get different classes of IP addresses. So before we get to the goodies, let's go over what is a network. A network is basically a group of devices like computers, phones, printers, and servers that communicate with each other to share data and resources. Over here. So when it comes to a network, those four devices, well, not four devices, three devices actually, you most likely will hear them often. So an IP address is like a digital home addresses that allow device to identify and talk to another device. Routers, on the other hand, allow us to reach out outside of our local network and communicate with another network on the outside. Switches allow us to connect devices together. So a typical network will be the demarc, which is the point where the ISP responsibility end and ours begin. So this is where the cable will go into our home, connect to the routers, and then from the router we can connect that to a switch and then all of our devices to the switch, because that's the purpose of a switch, is to allow us to connect multiple devices together. Well, not together, but to the network. And then we have a firewall, which is tie everything together, that protect our network by filtering bad traffic from coming in and allow good traffic to go out and come in. So firewall is like the security guard that protect everything. So it filter and block unwanted traffic. So a good example of a network would be when you send an email, your computer communicate with the mail server using the network. The router makes sure the message leaves your local network and reach its destination securely. So now let's move to IP addresses. Okay, for this one, let me share my screen. Okay, guys. So let's go over IP address classes. We will just focus on IP address version 4. So this is my screen. Let me bring the notepad here so you guys can see what I'm about to do. Oops. Okay. So when it comes to IP address, we have different classes. We have class A through class E. Class A is the biggest one that give us more usable IP address to use. So usually big business, very large organization usually use that IP range. And then we have class B, which is for medium network. We have class C, which is for small, which is usually our home. And then class D and E, we're not gonna see them in productivity or in the real world, because E is for experimental and D is for multicast. So any IP range that you see from the range 1 to 126 will be a class A. I'll go over what the slash and the subnet mask is in a little bit. And then any IP range from 128 to 191 will be class B, and then 192 to 223 will be class C. I don't know if you guys notice, there is no 127 is missing. Is because 127 is reserved for loopback IP address, which I believe is, let me type this here, which is 127.0.0.1. That's the IP address that that is reserved for loopback IP address. So you can use that IP address to test your NIC connectivity. So now, let's see what we have. Well, before I get into subnet mask and the CIDR notation and all that stuff, let's finish with the note. So when it comes to IP address, we have we have public and private IPs. So not all IP you see are visible to the outside. So we have three class of IP that are in the private range, and they are 10 to 25, and then class B 172.16 to 172.31, and then 192.168 to 192.168 to 55 to 55. These are private IP addresses. They are not routable to the outside. So even if you give someone this IP address, any of those IP addresses, they won't be able to do anything with it because it's not routable. And one of the most popular private IP address most people are probably familiar with is the default gateway, which is the home IP address from the router, which is in the range of 192.168.1.1. So now let's move to public IP address. Those are the IP addresses that you should not be sharing with people, because if you let people know what they are, they can hack you. A lot of bad things can happen if people were able to get a hold of your public IP address. If you want to know your public IP address, you can go in Google and you can type what is my IP address, and then you will see it. It will be something in like this, like 4220 or whatever number you see is gonna be your IP address. So now, how private and public able to communicate with each other? That's where NIT come in. We have 4 different type of NIT, but just know that NIT is what allow your private IP address to go to the outside and to the public to come to the inside. So what happens is, let's say your computer IP address is 192.168.1.131, and then you want to communicate with someone from the outside. So once your IP address reach your router, it's gonna go through the process called the NIT, network translation. It's gonna take that IP address, it's gonna translate it to a public IP address so it can go to the outside. And then the same thing happens in reverse. So when the outside want to communicate with you into your home network, I think inbound or outbound, whichever one, I think do the opposite. Translate the public to private, so the data or resource you're looking for can get to you from where you are. So that's what is allowed that to happen, which is NIT. NIT is often used to map private IPs to single public IPs, allowing multiple devices to share one internet connection, pretty much because inside of my home, all of my device going to receive a 192.168.1 and then something else. But the moment any of those IP addresses reach my router, they all map to one public IP address so they can communicate to the outside. So that's why it's often, but that's not NIT only purpose. But let's move on. So this is the good part, breaking down an IP address. So let me bring up my notes so you guys can follow along. This is good for anybody that's studying for CCNA and subnetting. You know, I love subnetting, to be honest. Subnetting is fun. So let me quickly do this. Okay, give me 1 second, guys, so we can get the ball rolling. so we can get the ball rolling. Okay, perfect. So let's go over here. Okay, so in IP address, we're gonna break it down in IP address. So I'm just gonna use a very basic IP address, class C. So let's use 192.168.1.1. So this is our IP address, which is a class C IP address. And then we're gonna find out why is it a class C, how did we get to that conclusion. But there are a couple of things we need to know when it comes to an IP address. I'm not gonna go too deep because this is outside of the scope of this video. An IP address made up of 32-bit. So, but each section of an IP address is an octet. So an IP address have 4 octet. Each of these are an octet. And each octet is 8 byte, which is 1 byte. So in total, an IP is 4 byte, which equal to 32-bit. So that's pretty much very basic of the section of an IP address. So now let's move to the subnet mask, the /24 that you see. Let me erase my screen. Okay, so I'm gonna use the same IP again. 192.168.1. I was gonna use that 0 to be honest. And then /24. So now the /24 let us know which part of the IP address belong to the host and which part belong to the network. So /24, we have to convert the IP address to binary. Let me choose another color. Let me choose red since I'm Haitian. So let me represent. So we're gonna do 1, 2, 3, 4, 5, 6, 7, 8. That's the first part. We're gonna do 1, 2, 3, 4, 5, 6, 7, 8. Second part. We're gonna do 1, 2, 3, 4, 5, 6, 7, 8. Third part. That is 24 right there. So that's what the 24 let us know. And then the last one is just gonna be 0. Anything that's not on is off. That's how binary work. It's either 1 or 0. Okay. So now a class C IP address, all the ones are part of the network, meaning they don't change. They stay the same. So this portion of the IP address is the network portion, and then this portion is the host portion. So now we can turn this into numbers, decimal numbers. So that would be 255. So ones are always 255, 255, 255, and then that's 0. So 255 doesn't get changed. The host, we can change that to whatever we want. So now let me scroll up so we can go over we do see different slashes. So a /C is /24. So now let me do a /A and a /B. A /A is a /8. Just let us know that only the first octet will be network portion. So it will be 255, which represent 8 byte, 1, 2, 3, 4, 5, 6, 7, 8. And then a /16, which is for the class B, let us know 16. We will have 16 1. So it will be 255.255, which will be 1, 2, 3, 4, 5, 6, 7, 8. 1 2 3 4 5 6 7 8. That's it. So that's what the slash let us know, which part of network and which part of host bit. So this will be the network bit, this will be the network bit, and they don't change. They're always gonna be the same, because anything that is 255, you don't touch those. You can only touch the host portion. I already went over the slash 24 already. So that's how, whenever you see the slash, most likely in your home network, it will always be a slash 24, because class B give us the smallest amount of usable IP address, and that's what our home and local network use. So this is how we get the different classes and what a subnet mask is. Now let's move into subnetting. I mean, this is beyond the scope. Like I mentioned, I love subnetting, so I might as well keep going. We're gonna use the same IP address, so 192. We're gonna take a space, 1 1. Let's use 0, and it's a slash 24, which let us know it's a class B IP address. Okay, so we know 24, meaning we need 24 ones. So we're gonna do 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8, and then we need 80. 1 2 3 4 5 6 7 8. So now we need to write this down. So this will be 255, 255, 255. That's 0. So this is our subnet mask. So now when it comes to subnet, let's say we have a test and then they want us to subnet this IP address. So how can we do that? Well, in order to break this down into smaller network, we need to borrow bits, because remember, this portion cannot be changed, but the host port we can touch the host port. Before we move any further, there's a formula that everybody should know when it comes to this. So it's gonna be 128 64 32. Hopefully this is correct, because it's been a while since I do any network stuff. Oops, I forgot the 16. So we have 6. Oops. We have 16. We have 8. We have 4. We have 2. We have 1. And this number equal to 255. Just remember that. So you should know this number, so because each of these represent 1 0. I'll show you what I mean in a bit. So they want us to break this IP address into a smaller manageable network. So what we can do is we can take our IP address. Oh, actually, I made a mistake, but this I made a mistake, but it's fine, because this was 160, 192, 168. Yes. Okay. So in order for us to break this down into smaller manageable network, we need to borrow bits. So we can borrow 1 bit from the host, which will give us 2 network. So now we will have this 192, 168, that 128. So that's where the number I put to the side. You should remember it, because when you borrow a bit, whatever bit you borrow is gonna play a crucial part in knowing what is the number, last octet number is. So now this is gonna be a slash 25. It's no longer a slash 24, and then the binary will be 1 3 4 5 6 7 8 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8. I think that, and then that's it. And then 1 2 3 4 5 6 7. So now it will be 255 255 255.128. So this is the new subnet mask, which is the 128. And this is our new IP address. This. So now the beauty is when you go about a bit, we have to use the power of 2. So this is how it goes. So when you borrow it might be a new verse. I don't use formula. I'm only using the formula because I'm putting this in display, but I just know it in my head. So the formula I'm using might be not so correct. It's either gonna be 2 to the power of 1 or 1 to the power of 2, whichever one. I just know when you borrow 1 bit, you get 2 network. When you borrow 2, you get 4. When you borrow 3, you get 8, so on and so on. That's how I remember it, which is easier for me instead of remember power stuff and whatnot. So when you borrow 1 bit, let me go over here. When you borrow 1 bit, you get 2 network from that. When you borrow 2 bit, I guess it's power to the 2. I guess you get 4. Oops. You get 4 if you borrow 3 bit, which will be, this will be 2 times 1. This will be 2 times 2, and this will be 8, which should be 2 times 2 times 2, and you get the idea. And then 2 again, and then this will be, I think, 16. 2 times 2. Oops. I mean, this is not correct, but why not? Yeah, so that will give us 16 network, but we only focusing on borrowing the 1 bit, which will give us 2 network. We can have 2 network. And how do we know our network IPs, what it's gonna be? Again, we have to go back to the number I put over here. If we borrow 1 bit, the first network is always gonna be 0. That's 0. And then the second network will be 128. So now if we go below, so our new subnet for the IP is gonna be 1. Oops. It's gonna be 192.168.1.0. That is the first network. The second network we're gonna get is 192.168.1.128. These are our 2 network. We can make from the original IP address. Okay, so I know some people, they learn with formulas, but me, I find formulas to be a little bit of pain in the, but I don't use formulas, to be honest. So one thing you should remember, right? For all your network, your subnet, the first IP address and the last IP address in each network are not usable. You cannot use them. There's a formula for that. I think you minus the whole by 2, which means you get the number or whatever. I don't know, to be honest. The way I learn is different than how most people learn. I just know first and last are not usable. No need to remember any formulas. So this will be, those 2 IP address would be our first. So these two will be will be our first IP address on each subnet. We cannot use them. So since we cannot use them, we have to move to the next number. That's gonna be our usable IP address. So now we're gonna get 1. So in this network range, the very first IP address we can assign to any device is gonna be 192.168.1.1, which we can make that the default gateway. You can assign it to anything, whatever you want. And then for this one, so the first one is not usable. The last acted on each IP address is it's what we call the network ID. So the first number on each network from the last acted is always gonna be the network ID. So if in the test question they ask us what is the network ID for these two IP addresses, the answer will be 0 and 128. So the answer will be 192.168.1.0. That is the network ID for this network, and that 128 will be the network ID for the second network. So since we cannot use 128, we have to move to the next usable one, which is 129. And this is the IP address we can assign to any device on that network. So now the last one cannot be used. So how do we get the last one? Remember, the last one cannot be used. So if the second IP address on the second network begin with 128, that's mean for the first one, the last one is gonna be 127. So because the last one cannot be used, we have to jump backward again, or forward, whichever one, to 126. And then the same one, the last IP address is always going to be 255. That one cannot be used, so we have to move to the left one more time, which is going to give us 254. So now, this is a little bit messy. So now let me rewrite this again. So our network ID will be 192.168.1.0. Net ID will be 192.168.1.128. So now our first usable IP is gonna be 121.26, and our broadcast ID is gonna be 127. The broadcast IP is the IP address that's used to communicate to all devices on the in the network. So when you broadcast something, it goes everywhere. So the same thing will be here. First usable IP on that range will be 129 to 254. 255 will be the broadcast ID on that network. And this is how we break down, subnet, if I'm keeping the lingo, subnetting. So these will be usable IPs we can assign to any device. The 0, 128, 127, 255 cannot be used. So now this is very simple. So let me write down the number again. 120. Is it 120? Is it 128 or 168? Let me see. Let me double check, so I'm not displaying wrong information here. I think it's 128. It should be 120 because let's see. Yeah, 128 plus 64 is 192. Yeah, so it's 128. Yep, 128, 64, 32, 16, 842. Okay. So let me put this number down again so you guys can see what I mean. 128, 64, 32, 16, dot 4, dot 2, dot 1. So remember, when we borrow 1 bit, we get 2 from it. If we borrow 2 bit, we get 4, 3, we get 8, and etc. etc. So how do we get the first IP in that subnet, or the network ID I should say, right? So let me use the 64 for example. We're gonna get full network. Let's say that will be 125 126. If we're about 2-bit, our slash change to 126 because this is 125 126. So we will receive a slash 26 because about 2-bit, and then we will have 4 subnet. So now how do we get those numbers? So whichever number that you're borrowing from lane is the number that you start with. What do I mean by that? The first IP will always be 0 for the network ID. It always gonna be with 0. So if how about that? So the first one will be 0. So I'm gonna show you guys if about 2-bit, which is gonna be 4 subnet. I'm gonna show you the numbers. So it's gonna be, so the first number is gonna be 0. The second one now is the number that we borrow lead on, I guess we can say. I don't know, whatever work for you guys, which is 64 because it's about 2-bit. So now the second one will be 64. Now how do we get the third one? We add 64 to that, which give us 128. How do we get the next one? We do the same thing again. Wait, let me see. 60 0 1 2 3 120. I'm stuck at math, so let me see. We do 128 again, which give us, oh, this is bad. Yeah, I'm really suck at math if I'm being honest. Well, if I'm good at subnet, doesn't mean I'm supposed to be good at everything. I think it's 256, but no, 226. Let me see. Let me see. Maybe I made a mistake somewhere down the line. But is it 64, right? So that is correct. Let me quickly check something real quick. Let me see. So oh, I know what I know what's the problem, to be honest. You don't add the same number, you add you add what you borrow from. Okay, that's what they're confusing. So it wouldn't be 168. So this one would be, oops. So this one would be plus 64, and then 64. You keep adding 64 to all the one to get the to get the rest, which will give us 192. Okay, that was the confusing. Yeah. So this will be our full network for if we were to borrow full 2-bit from the host portion. So these will be always, they cannot be used for anything. They will be our network ID. You know, of course, we get the rest of the number. So this will be 1 to 162. 163 will be the broadcast for that one. This one will be 65, 126, 127 cannot be used, and this one will be 129, and to 190, I think 190, because 191 cannot be used, and then 193 to 254, like I said, 254, and then 255, and then 255. So this will be our full subnet if we were to borrow 2-bit from any network on that range. So as you can see, I don't use formulas. That this way it's easier for me instead of remembering power to things and whatnot. So very easy and simple. I know my handwriting is a mess, but I'm pretty sure you guys get the idea. So if we were to borrow 2-bit, we're gonna get a /26, and then these will be our full subnet: 064.128.192, and the middle range will be usable IP. The last will be the broadcast ID for each subnet. So that's all the, let me see, did I miss anything when it comes to IP address? I mentioned the what else? Nope, I think that's it. Yeah, which was pretty simple. I mean, I think it was simple when it comes to subnetting. So the same thing. So the same thing for any range. I think class A is the hardest to subnet because you can get confused, even though you're working on the second bit, but when you're creating the network, you have to move to the last octet to get the real IP address. But when I'm studying for my CCNA, I will also create videos for that and post on my channel. So for anyone who's studying for CCNA and have trouble in subnet, I can help you with subnetting if you need. I can help you because to me subnetting is easy. It's not that hard. So that's it. So that's all there is into that. So I show you guys the different part of an IP address. We got full octet. Each octet is 1 byte, and which is equivalent to 8-bit, and IP address is 32-bit, which is 4 byte. So you know, we talk about what is the we talk about let's go back to, so okay, we talk about subnet, prefix, the different part. So now let's jump to the real the real lesson of the video. So every network device is an interface. So when it comes to Linux, you most likely will see stuff like ETH0, WLAN 0, EMPS3, etc. I already went over IP address. I already went over network mask, net mask, and prefix. Default gateway, I briefly mentioned that it allows us to communicate to the outside world. DNS server, which is port 53, allow us to, well, not us per se, allow the system to convert numbers to words. So when you type Google in your web browser, it knows to translate that to numbers. That's pretty much the job of DNS. Change numbers to letters. I mean, there's more to it than that, but that's pretty much all. That's pretty much what you need to know. If someone asks you what is DNS, just convert numbers to letters. Oops. Okay, so now, okay, I went over all of these. I'm not gonna go over them again. So an IP address is a unique identifier for a device. We can either assign it manually or get assigned by DHCP. DHCP stands for Dynamic Host Configuration Protocol, which I believe is port 167 and 168. I think port 169 is TFTP, which is true. Okay, well, this is not a port number videos. Okay, let's move on. When it comes to IPv4, the slash is /24. When it comes to IPv6, it's /64. The net mask define the subnet boundaries, which we saw when I was showing it. I already went over what default gateway does. DNS resolve domain names to IPs. Simple. 4.8 and 4.1 is a very popular DNS servers, which I think 8.8 and 8.4.4 is the Google DNS server we can use. So now Since when it comes to the Linux Plus, Debian and Red Hat is what they use, so that's what I'm going to use for my video as well. So when it comes to networking in this machine, there are a couple of files we should be aware of, and they are the etc network interface, which is legacy static config using auto and iface line. We have the etc network interface D, which use the extension CFG, and then we have the system D network, and then the .network extension, which used in modern system, and then the DNS resolve get stored and resolve config if your system is not being managed by network manager. Let me quickly display each of them real quick. Where's my terminal? Okay, so if we do etc network, oh, this is a file, so it's not gonna work, so I have to do, well, let's do D first. So it's empty, but you can create your own file and put in there for managing the network manually if you want to. So let me do cd so we can look at the interface file. Oh, sorry, you know, let's just go back. Let's cat interface. As you can see, it's empty. I mean, it's not really empty, but it doesn't have any substance in there, but you can add your own stuff in there to manage. And then we have the network one, which is located in systems etc system D. You know what, let me take my face and put it right here. Let's do Control C to cancel out. Let's do let's do system D, and then let's do network. Same thing, there's nothing inside of the network directory because you can add your own. The only thing is the file in there either have to be in extension network or don't have no extension at all. So let's quickly go over how you can edit each of these if you wanted to. So the first one is the etc network interface. This is a file, not a directory, so you can have stuff like enp0s3 in there as a profile or config file, and then you can put this. Very simple. The auto simply mean that the interface will be turned up when your system boot up. This is just let us know that the interface will be static, and then we can just put our information in there for the network. So IP address, network mask, gateway, and the DNS, whichever that one is. So let's keep it moving. We have the next one, which is the interface D, which is let's see, I think that is well, okay. So we can, if we go into interface D, there's nothing in there, but you can add your own stuff in there. So this folder let you split interface configuration into separate file, but it only works if your main interface file include this line. Enable modular loading. I mean, it does. Where is it? Yes, right here. Source etc network interface D. So it has to include this for it to work. And for the naming convention, when it comes to this directory, like I mentioned before, they either don't have an extension or they have the CFG extension for it to work. And then the input is similar to the one above. Same thing, auto iface let us know the interface will be static, and then the name of the interface, and then you just input the network information. Easy peasy. Now let's move to the system D, if that's what is managing your network. Now let's look at the modern way using system D, network D. You will create that network file inside. Here how you can use different. You can have a one for static, one for DHCP, you can have one for VPN, whatever. You can have as many that network you want. Just know the number you put in front is gonna be in the order that they get load up. So the number control load order, it mean how they're gonna get load when you restart your network service or Debian, however, whichever one you want to call it. And this one is a little bit more complicated. Well, I wouldn't say complicated, different than the previous name, because you did the match, which we didn't have before. That just matched the interface, letting us know that the configuration inside of this file will map into the interface, into this interface, which is the ENP0S3, and then the network information, same thing. So it defines criteria to match the network interface so that the configuration apply only to that interface. And then also this will be static IP address, because we have everything in here, or we can have a DHCP, just that. I don't know why would you want that, because the machine automatically get its IP address from DHCP, unless you have a different DHCP server you wanna, or unless you have a different interface you wanna create a DHCP file for. You can do that. Once you finish doing all your configuration, you can use the systemctl restart systemd network for that. For my system here, I don't think systemd is not what is managing my network, so this will not work. Systemctl status systemd network d. As you can see, it's disabled because that's not what is managing my network. But if I type nmcli, this is you get the information. That's because the nm is stand for network manager. That's what is managing my network, is the network manager, daemon, system, process, whatever you want to call it. That's what is managing my network. That's why this one worked. So if you want that, you have, well, systemd already disabled, but if I wanted that to manage my network, I have to enable it. So let's do clear. So I don't need to install it. If I didn't have it installed, I could use the sudo apt install systemd network, and then I will enable it if I want that to manage my my network for me. In Debian 12, which is what I'm using right now, network manager is what manages your network for you by default. So that's why when I type systemd, it's disabled, because by default that's not what is managing the network. So if you want to switch, you have to disable one. So if I want systemd to manage my network, I have to disable network manager. Just know that the file that you created inside of the systemd network have to have a permission of 644. They have to be readable by systemd, which is 644. We already went over what the DNS is, so let's see what is managing my resolve CL status. So that clearly let me know that that's not what is managing. That is not what is managing my DNS for me into the system. So let me do nope, that's not gonna work. Let me quickly check something real quick. Let me quickly check something. Okay, never mind. Let's keep it going. So this is not what is managing my for legacy system, once you finish making your changes, this is how you bring that interface down and up. For the change to apply, you type sudo if down, the name of the interface you would like to bring down, and then if up to bring it back up. And that's all there is to Debian when it comes to managing your network. if you want to do it manually, or if you want to do it through DHCP, or if you want to let your system do it for you. So these are the essential files that you most likely will encounter, and they are the interface file, the interface D directory where you can create your own config file, and then the system D network where you can create as many network profile you want for whatever you want, and then for the name resolution, which is located in resolve conf, if that is what is managing your DNS for you. So now let's move on to Red Hat. Let me switch device. Here you will see that the process is almost kind of the same, the name change. So let's break down how RHEL 9 or recent version handle network. Unlike Debian, RHEL use network manager by default, and most configuration is done through connection profile in the network manager CLI tool. So the same thing, we have two main files that we care more about, which is the one file, one directory, because the network manager conf, and then the directory is the system connection. So let's quickly check what is inside of each. Let's go. So okay, the first one is cd etc network manager system connection, and then as you can see, I have 3 files in there. So let's check them out, because last time I checked there was only one, but now I see 2 extra one pop up out of nowhere. Not sure why they there. Let's see what is inside of them. What just happened? Sudo cat. Yeah, last time I checked there was only one. So this is my connection right now. This is what I'm using, that connection. As you can see, the file config is a little bit different. We have the ID, which is the interface. We have the type, the Ethernet. We have priority, interface name. We have the method, which is auto, that let us know it's getting the IP address from DHCP. So but now I'm curious about the rest. Let's do sudo cat static. What is it? Static 1 connection. I'm not sure where this one came from, but okay, I know where it came from. I think my internet went down, so I guess it created one, because this is my RHEL. This is my OPN since IP address, and then this is my RHEL router IP address. Oh well, okay, it's still good connection. Okay, so now let's check out the other file, which is, we're gonna do cat etc network manager conf. Same thing in here. Everything is commented out, meaning this file is not being used, but you can edit it for your own liking, because it controls how network manager behave. And then we have the resolve conf. We can check that one out to see if that is what is managing DNS in the system. Yes, because when we check Debian, we didn't get this. So you can see that name server is the default gateway, and it's being managed by network manager, because previously we saw that network manager is what Red Hat used by default to manage the network. So I think it would be the same thing in here too. If I do sudo system systemctl status. Is it system D network D? Network D. Well, maybe I got the name wrong or something, but yeah. Let me quickly check. Maybe I think I got the name wrong. System. Definitely got the name wrong. Okay, well, anyway, let's keep moving. Because if I do the same thing for, if I do what is it? If I do network service, I think it's because I'm using. Let me clear this. It's a bit. Let's see. Where's the name I'm looking for? Oops! I think I'm way ahead of time. Oh, okay. Let's see. Okay, I see what I did there. It needs to be network. Yeah. So it's active and it's running because that's what is managing my network, the network for the system. Okay, so let's keep it moving. So we have the host name. We do need the host name because that's what we use locally to identify in the system used for identify our system and DNS also. So now let's get to configuring some of these file and directories if you want to put stuff in them to make our network more manageable. So just know that when you come to the network manager system connection location, things in there have to be in that nm connection, and then they have to have a permission of 600, which is read and write permission, and the file have to be owned by root. So for example, inside of that network manager system connection directory, you can have a static connection, and inside of it you'll have this. Just let us know the connection, the ID, the type, the interface auto connection, which is true to auto connect. The method is manual, which is static, and then the network information, we're not using IPv6, so that's gonna get ignored. So pretty much I just went over all of these. So it's the same thing. We can have a DHCP connection. All we have to do is put the basic information in there, and then put the method into auto, which will be for DHCP connection. Real simple. So after you finish doing any of those editing, just know you have to use an nmcli connection reload to reload the file into our system so the system can pick it up. So if we do I'm not doing any of that stuff, but I'm just gonna say connection show. It will show us our connection. As you can see, we have a couple of connection. We have the static one, which is the ends 160. We have N60 again. Those are our connections. So let me quickly check something real quick and see what's gonna pop up here. Okay, so we do have the /64. I don't know where that come from, but yeah, anyway. Oh, as you can see, there it is, the look back address. When we were going over the why the 127 was missing, and then we skip, because I think for class A it's 1 to 120 127 and 129 to 191. Yes, so this is why the 127 doesn't get used, because it's for loopback testing. That's what we use. So that's why so when it comes to modern system, the best way to manage the network connection would be to use the nmcli, because when you manage them manually, you more prone to make a mistake or put the wrong information in there and mess up your connection. So using the nmcli is a better way to manage and configure your connection profile. I'm not gonna create a static connection, but this is how you will create one. You will type the command connection add, type is Ethernet, connection name will be static, if name, that will be the interface name, then the IP address, and then the slash, the gateway, and then you're gonna add the static DNS server IP address, and then we're gonna bring the connection up for the static one, which is the name of the profile. And then to delete it, you just type the name of the profile you created, which is static C1. So if you wanted to use it after creating it, you just do an nmcli connection reload for that specific profile to be reload and override what was there previously. So now let's move to the conf file. So this file controls how network managed VS, especially how it interact with DNS, DHCP, and systemd resolve. So inside of that conf file, this is what you can put in there. You can put the plugin interface CFG, which is the script that let us the system know to use the default the script for interface configuration. We can put a login information in there, so when we're checking the login for the connection, we can see what happened. We can also ignore the systemd resolve DNS by putting a none. So what that does is that it disables DNS integration with systemd resolve. So that means network manager won't push DNS setting to the system resolver. Useful if you want to manage DNS manually or with another tool, which we saw an example here. We want DNS to be managed by systemd resolve. We just type the name of the tools that we want to manage our DNS for us. We can also do DHCP client logging, level debugging. I think that's for if something happens, so we can see what went wrong. So this increase login verbosity for the DHCP subsystem. You will see detailed message about lease request, renewal, and failure grid for troubleshooting IP assignment issues. The debugging level. So just like before, after you finish making all your changes, you have to restart the network manager service so everything can load up properly. You can also change your one thing to know, when you change your host name on the system, you have to change it in the host file. So if I do, let's see, let me quickly check something. Let's do sudo hostname ctl. So static hostname is cyber92, the machine ID, boot ID, virtualization is VMware. I'm using Red Hat Enterprise Linux 9, kernel 5, and etc, etc. So this is my host name. So let's say I did want to change my host name. I will also have to change it here. Oops. I also have to change it here. Remove this and put the new name here, because it's not gonna change in the host file. So when you do the systemctl hostname, it update happen in the hostname, but it doesn't update it in the etc host file. So let's do, well, I already went over this, but I think we saw what is managing our DNS, which is network manager. Yep. So just know that any file that you created into any of these folders or file, you need to set the right permission to 600, which give the owner read write and everyone else no permission at all. So that would wrap up this section when it comes to essential file for managing your network. So now let's move on to some command that you might want to use in viewing your network information. So the first one is the IPA. I think that stands for IP address, if I'm being honest. This one shows us a lot of useful detail about our connection. We can see our IP address here, 192.168.157. We have the slash for the subnet mask, and then the broadcast ID, which is this 255. We have the maximum transmission unit, which is 1500. We also have the one for IPv6. We have the loopback IP address, which is a class A. There's not much to go in here. We do have a couple of MAC address in here. MAC address. This is broadcast. Whenever you see FFF, just know it's the broadcast address. So we also have IP brief, the command. This one shows us less information, but it keeps everything simple. Let us know the state of the connection, the name of our interface, IP address, and slash, and then this number. We also have IP link show, which will show us the link, the status of our link. We can do IP link show. It shows us it's up. We can also put the link down. We can do sudo IP link set device name, which is the if 0 to down, or we can do up. If we do up, it will bring down the interface down, which is like turning it off, up, turning it on. We can also assign IP address to our interface with the sudo IP add addr command. It's very simple. Sudo IP addr, add the IP address and the slash and the interface. Just know you also have to do default gateway separately. If we want to see our routing table for this, we can do IP route show. It let us know that our default gateway, which is this IP protocol, is static. We do have a whole network in here that any IP in that range will get. We should be able to communicate with them, and we should be able to communicate with them, and they should be able to communicate with us, because that's what this means. The whole network is in the routing table, which means whenever IP address from this network come in, it will get accepted. Same thing, we can add a default gateway. Same thing we did before. When it comes to the default gateway, we don't really need interface for that. So now let's move to ping. Ping is simple. Ping send ICMP. I think that is Internet Control Message Protocol, if I'm not mistaken. That's what that stands for. It's in ICMP echo request packets to a host to test network connectivity. One thing to remember when it comes to Windows machine, ICMP echo request is blocked by default. So if you're pinging a Windows machine, you're not getting any response back. Don't think the machine is down, because most likely it's because it's not accepting echo requests. So C is limit the number of packet. In Linux, when you type ping something, it ping it non-stop. It's like a little flooding attack. It's like a little ICMP flooding attack going on when you do that. Everything else is pretty much explained to you. The numbers is the IP address, and then the DNS, which is the same thing, kind of. Now we move to ports and connectivity. So netstat used to be what we used to use, but now it's being replaced by ss. So if I type sudo sstulpn, we do have connection, but they're not anything important because I don't do anything on this virtual machine for there to be anything of interesting here. So you're not gonna see anything interesting in here. It's just, I don't know what that. It's just a bunch of ports not doing all listening or unknown. So if we do netstat, it will be almost similar to that. Netstat. Oops. Forget. Yeah, it does the same thing. Show us a couple of listening UDP port, TCP port, but no will IP address is actually listening or waiting for anything because I'm not using anything that will initiate a connection or listening on something. So the flag for this, the TULPN, T is TCP, U, UDP, L is for listening, P is for processing, N is for the numeric address. But nothing is going on, so you're not gonna see anything. So now let's move to web and API access. Curl is very useful. You can do a lot with curl. So curl transfer data from or to server using various protocol HTTP or FTP. So we can do curl I think that is for headers. You can do V for verbose. You can see a lot of good information by using curl. You can just, let me see, if I do curl, is it capital V? Well, let's do this one instead. Let's do -I instead. Let's do, as you can see, that's the header for www.google.com. So you do get to see the header. We get the cookie. There's a lot of good, useful information in here. We do have a HTTP status code 200 request. That's mean now we send a HTTP get request and then we receive a 200 status code back. That let us know our request was successful. If it was a 400 or a 300, then it would be, I think 300 is redirect, 400 code is client side errors, and then 500 is server side error. I think someone can fact check me on that one. So now let's move to wget, which is used to download content from the internet. So we can use wget to download an ISO. GitHub usually have a lot of useful content like ISO, password lists, sec lists. If you want to download sec lists into your system, you can use wget for that. You just have to go to GitHub, get the HTTP, and then just wget it into your machine. Boom, it's going to download it into your system. So wget is very useful when it comes to downloading real fast. So download large file with zoom capability, avoid hogging bandwidth and sharing environment, automate download and script. So wget is very useful. So now let's move to basic network management command that we can use to manage and configure our network. So nmcli is what is the default service, I should say, that manage our network. So I think I already did mlcli's device. I don't have a lot. Oops. I only have one, which is static. Connection is static. Interface, it's connect. We can do connection show. It show all of our connection, and with the UID, the type. we can use it to add a full connection into our system, name it and everything. We can also delete it. With CLI, you can do a lot with the network manager CLI, if that's what you prefer to use to edit your network profile and manage your network. So now let's move to the managing service. So to restart your network manager is very simple. We use sudo systemctl restart network manager, and that's pretty much what you use to restart any service, FTP, HTTP, Apache. To restart legacy network, usually pretty much same thing. Sudo systemctl restart, the name of whatever you want to restart. Check status, systemctl status, whatever you're checking. Do I have SSH installed in here? So let's do systemctl status SSH. Is it SSHD? I'm not. Is it D? Okay, so it's D. So as you can see, I do have SSH running in my device, and it's running and it's enabled. So I can use systemctl status. I can use enable. I can use restart, reload, stop, all of that to manage the service that you want. So this is enable. So that's mean it's going to get start whenever my system is booting up. So that's what when you start it currently, but so the difference between enable and start is that if I start the service and I didn't enable it, every time I shut down my device, I'll have to keep starting it again. But if I enable it, I only need to do that once, because every time I restart my computer, it will automatically start. So those how you manage check status. For logging, well, not for log or store inside of here, we can do cd var log. This is where all type of log is located. So so this is where you will go to view error message for boot. We have boot log, we have firewalld log, we have VMware log, we have tuned inside. So this is where you will go to view message, and we'll go to what's going on into your system. I think we have more if we do LSA. Yep, so var log is where logs are located. Let me clear this. And you can also use journal CTC to view logs also. So we can type IP for interface state. We can do, let me go home. We can do IP brief link. If I'm being honest, a lot of these comments do the exact same thing, if I'm being honest. So not really sure why we have so many of them. Because if I type IP brief, this is almost similar, to be honest. If I do no, not that one. So they all pretty much show different information, but they all is in regard to your connection status of your connection. So we do have IPA and IP route. IPA is give you more information. IP route will display the routing table. I went over that. Is the, over that already. DNS test, we can do ping, www, Google. It should ping, but it will, but like I mentioned, when you ping on Linux, it keep going forever. We can do dig to test our DNS server if it's working. Dig Google. We should get a DNS server IP address. but the one we're using is port 53. But we do have a 150, we do have a 142 here, which is for google.com. We dig, you can do, I think, is it dig X? I don't really use dig that much. Whenever you want to know more information about a command, you can always type the main command. It will let you know, or you can do apropos, I think. Is it apropos dig? Yes, so apropos dig will pretty much bring anything that has anything to do with dig. Anything that has dig in it, any command. So apropos is different. Apropos is more like to look for a comment that you forget about though. So the two best useful comment you should use whenever you want to find out what a comment does is you can do dig-h, or you can do the main page for dig, and then it gives you brief information. It gives you everything you need to know about the command. So we already went over resolve conf genoctl. We went over that in a previous video, but you can type it to view log ctl-u. The u is for the name of the service that you want. So this is to view log, but there's nothing going on. You're not gonna see much. We can do IP route to test our routing get it. So that worked. When it comes to RHEL use firewall CMD for the firewall. I don't think UFW is not found in RHEL. I don't know if you can download it, but it doesn't found. But Debian use UFW. So for example, let's say I wanted to see, probably not gonna see anything because there's no rule. I didn't set up any rule in this. Let's see what is gonna be this way. But let me quickly switch to Debian real quick while that's running. So if I do UFW, let's hope it's installed. Nope, it's not installed. Let's that run and let's go back. Let me run it with sudo and see if that changed, but I don't think we're gonna receive anything because I didn't set up any firewall rule for this system. It's not gonna show anything, but that's how you will see. I guess it did come back with something, but nothing in specific because there's no, I didn't add up anything, to be honest. I mean SSH and DHCP6 client interface. So I did show this. I'm not gonna SSH. I'll have to use external machine to SSH into my RHEL, but I'm not gonna do that. But we can check the status or start as SSH. Let me see. I did show it here, so quickly let me see if I have CTL status SSH. So it's running also, so that mean if I want people to be able to SSH into my machine, I have to allow it to the firewall. So if I do sudo ufw, is it list? No, is it status? Yeah, it's status. So it's inactive, so I can do sudo ufw enable. And then I can do, I think I don't need to do start, but yeah, start is not comment. So now if I want people to SSH into my machine, I have to do sudo allow 22 or the other actually word, which is SSH. Now if I do sudo ufw status, now I should see SSH is the rule that I just added and it's active. That's one way. And then I can say I can remove it, I can delete it, I can deny. You can add this is how you will you can use add rule. There's also iptable. I don't know if iptable is installed. Yep, iptable is not installed. Oh, let's see, is it iptable? Yeah, iptable is not installed, but iptable is another firewall you can use, but you have to install it to protect your system. But when it comes to RHEL, we use firewall system D. I already went over the UFW. So for example, let me add SSH into my rule. We're gonna do sudo firewall cmd. We're gonna add service SSH and then permanent. Let me see. Let's do this. Okay, SSH is already enabled because it's already here, so that's why I didn't do anything. SSH is already here, so but this is the format that you will use if you want to add a rule into your firewall. So you can not put the permanent if you don't want the rule to be permanent, or you can add the permanent. So this is some basic command for the firewalld to use. So you can do sudo firewall cmd get active zone. You can create zone, you can list service, you can add by name, or you can add by port, TCP or UDP. Whenever you add something, you have to reload the firewall so the rule you just add can take effect. So you can also create firewall, sudo firewall, zone, public, change interface. So you can really get very complex and granular with this, and it's the same thing with UFW. So you can install it, enable, disable, status, allow by name or by port. You can do sudo deny from this IP address. You can do sudo UFW default deny incoming, so set default to deny incoming. Any connection coming will get denied. You can do sudo UFW default allow outgoing message to go out. So so when it comes to Debian, and well, these are the, I mean, we do have iptable, which a lot of people use, but these are very popular if you don't want to use third party, like, I don't know, maybe you want to download your own firewall into your system. So you can use what the system already come with. TCP dump, it's for network monitoring. I'm not gonna go over TCP dump and Wireshark. Maybe I should create a separate series for Wireshark. I love Wireshark actually, but Wireshark is not installed in here, so it's I'm not gonna bother installing because I'm not gonna bother install Wireshark. nmap, same thing. I'm not gonna go. These are good, but these are outside of the scope of this video. But it's good to know you can experiment with them on your own. TCP dump. I don't even think TCP dump. I don't think TCP dump is in this yet. You have to download it. And the machine that I have that have TCP dump on it. Let me see. Do I have Kali Linux anywhere? No, I don't have Kali Linux in here. Do I have Kali Linux in virtual machine and VirtualBox? Nope, I don't have Kali Linux anywhere close by, so I could do a demonstrate how TCP dump work, but you can test it. So a very basic command you can use, you can do TCP dump -d. That would let you view all your interface, and then you can do TCP dump I for interface, and then that's the most basic one you can use. That will pretty much dump all the traffic from that interface into your screen. You can save it into a file, and then you can view it afterward. nmap, iftap is not found. All of these are network tools you can use to monitor your network. And then we have iptrap-ng. To be honest, I should have not include these into the video because they serve no purpose into what this video is about. But I guess now that you guys know about them, you can do your own little research and experiment with them. Now let's move to advanced services, DHCP and DNS. So if you want your interface to receive IP address to the DHCP service, you can just type this into the command line, and then it will automatically set that up for you. We can take a look into cd var lib DHCP lib. That's the DHCP. Let's see what's in there. There's nothing in there, but you can create your own DHCP.list and put the correct information in there. DNS tools, I went over DNS already. No, not dig. In NS lookup. NS lookup is name resolution lookup. So if I do NS lookup google.com, it's gonna give me the non-authoritative IP address for Google, which is 142.251.35.174. That's what the DNS lookup does. You can DNS lookup. You can also do stuff like you can do stuff like type echo. You can do type A. You can do txt for text file. All of these are Google text file, or it's not text file. The name is not on top of my head, if I'm being honest. Text record. That's what it is. Text record. So with NS lookup, you can do you can look for different record, I should say, when it comes to that. You can do type txt, you can do A, you can do double A, triple A, you can do mail record, which is MX, you can do CN, CNAME, I think if you do main ns lookup, you will see how to fully use it. I already went over how to change the host name of your system. We arrive at the end of this. I'm not gonna display any, well, I mean, some of them I can display, but I'm not gonna do anything that's gonna require me to do too much, so I don't want to mess up this up. I already went over brief IP address. That's to view interface. You can bring your interface up or down. You can do IP route show to show your routing table. You can test it by do IP route. That would be the same thing. I forgot. It's been a while since I used ns lookup. No, I forgot the command. There's a similar command for Windows that you can do that to trace it. I think trace it or trace route or something like that. For port and connection, you can do sudo ss, and then for TCP UDP listening port, and then the number for listening. So if you type that, you don't see anything. You can open your web browser and do things. You will start to see connection pop up everywhere. Curl is to view header. You can do so much with curl though, but the one that most people use it for is to grab headers, and then we can use wget to download file online to our device. We can view our resolve config and our host config file just by going into the specific file, and then we can restart whatever service we want by using sudo ccl restart network manager, whether that's FTP, SSH. While as long as you know the name of the service, you can pretty much restart it, start it, end it, reload it. I think my previous video that I recorded was all about that. And then we can use journal ccl to view log for a specific service if something went wrong or you receive an error. And then for remote access, we have two options. We can use SSH to remote connect into a device, or we can use SCP. Well, SCP is not really for kind of remote access, but it's mostly like to securely transfer file from one machine to the next. And that's it, guys. I know this is a long video, but I hope you guys find it useful. If it wasn't for the subnet section, the video probably would be way shorter, probably 1 hour. But I hope you guys enjoyed this. I hope you guys learned something from this video. Thank you for watching. Until next time, and thank you.